from the Economics Tutoring Center, and today we're going to be working on production possibility curves, or PPC, and opportunity cost. Alright, so for this problem we're looking at the chart form of the production possibility curve, and the question we're attempting to answer is what is the opportunity cost, or OC, for one more butter? So what this is also saying is how many guns do we lose when we try to gain one more butter? Now what you'll notice in this chart is as we move from point A to B or anywhere down, we're not necessarily just gaining one butter. So what we need to do is adjust the numbers so we can find out how many guns we lose for just one butter. So what is the opportunity cost for one more butter here? And we're going to put the opportunity cost in this column. So moving from here to here, how many butters are we gaining? 2. And in the same interval, how many guns are we losing? Well, 30 to 29 is 1. So if we want to know what the opportunity cost is for one more butter, and we're gaining 2 butter, and losing 1 gun, we can adjust the ratio by dividing how much we're gaining, or how much we're losing, so this gun side. How much we're losing 1 gun by our gain, so it's a loss to gain ratio. So you can also do this just by adjusting the ratio, so dividing both sides by 2, because we want a 1 butter to some gun. So when we divide by 2, we get 1 butter to 1/2 gun. So the opportunity cost for one more butter is 1/2 gun when we're moving from A to B. And one important thing to realize is that even though we're asking for the opportunity cost for one more butter, we're presenting it in the units of gun because we want to know how many guns we're losing. So even though it's asking about butter, we're representing what 1 gain in butter is in terms of guns. Alright, so now that we've done from A to B, we want to move from B to C. Again, answering the question, what is the opportunity cost for one more butter in this interval? So, as we move from B to C, on butter, how many are we gaining? 2 to 5, that's a gain of 3. And how many guns are we losing? 29 to 26, that's 3. Okay, so we're going to do this one in regards to the loss to gain division to make it a little bit easier. So we're automatically going to assume, or not assume, we're going to use 3 gains and 3 loss. So if we divide our loss, 3 guns lost, all we have to do is divide that by how many we gained. And how many did we gain? 3 butter gained. So again, this is the same way to approach a ratio problem. You just are no longer looking at a 1 to 1/2. We're just skipping right to here. And we have a 3 over 3, so what is that? 1. So 1 gun. Because we lost 3, but gained 3. So our loss divided by our gain is 1. Okay, moving on to the next. In the interval from C to D, what is the opportunity cost for one more butter? Moving from 5 to 9, we gain 4. Moving from 26 to 20, we lose 6. Going along with this same process, if we're losing 6 and gaining 4, then our opportunity cost is 3/2 gun. Okay? Alright, now I'm going to do one more example this way, and then we're just going to continue with that one. But different students learn in different methods, so I want to make sure I'm covering both of them. All right, so going back to the ratio method, if we move on the interval from D to E, what is the opportunity cost for one more butter? 2 gained, 9 lost, because we're moving from 20 to 11. So, 2 butter were gained, again 9 to 11, and from 20 to 11, 9 guns were lost. So, we're going to do this the math way with the ratio. We want to know what the opportunity cost is for one more butter, so that means we need a 1 on this side of the equation. So we're going to divide both sides by 2, and our opportunity cost then is 9 halves gun. All right, so for one final interval, moving from E to F, what is the opportunity cost for one more butter? Moving from 11 to 12, we have a gain of 1. And moving from 11 to 0, we have a loss. Sorry about that. We have a loss of 11. So this is a fairly easy one. If we divide our losses 11 by our gains 1, 11 divided by 1, that's 11 gun. And so also if you like patterns, you'll realize that the opportunity cost is increasing as we move along. So it started at 1/2 and now we're all the way at 11. But now we have a weird point, G, where we notice that all of a sudden we have 30 guns and 10 butter. But here we said we had 30 guns and 0 butter. So how is this possible? The trick is this point is actually impossible. So we're going to go ahead and draw a sample graph, but you're going to learn more about this in the next video. So there's 2 ways to approach a problem, the chart and the graph, but this is a little bit easier to understand via the graph. So I'm going to sketch it out real quick. If we put guns on the y-axis and butter here, on the x, and we plot our extreme points, which means when there's 0 at one and our maximum at the other, 30 and 12 is 12. And then for PPCs, if you were to plug all these points in, you'd get the general idea, but I'm just going to go ahead and draw the line so you can become more familiar with it. And now I'm going to try to plot point G. 30 and 10 it says, which puts us somewhere over here. Now, the idea of production possibility curves is that anything on this line is considered efficient. Anything inside is possible, we have the resources, but it's not efficient because we could be making more. Now, anything outside of this line is impossible. So because we know that this was one of our points, and all of a sudden we're saying 10 and 30, and that's outside of the curve, this point, G, is impossible. All right, so that's it for this example. If you need any more help, you're welcome to come to the tutoring center. Be sure to remember that notation differs from professor to professor, so check with your instructor. But otherwise, today we learned about 2 different methods for calculating production possibility curves and opportunity costs, and I hope you found it helpful. Goodbye.